Okay, so let's just zoom in on this question here. We've got to simplify this, and we're going to simplify it into the form of a multiple of x minus a number divided by another multiple of x minus another number. A, B, C, and D. Oh, and they are integers as well, which means whole numbers, of course. So if we ended up getting a fraction, it's good job we ended up getting integers, otherwise we might have lost a mark there if we hadn't noticed that. And if we got like a decimal, we'd have to multiply it by 2 or 3 or whatever. So the first thing I noticed was that we're dividing something by a fraction. And so I'm going to remind myself of this rule that whenever I divide one fraction by another, or anything by a fraction in any case, it's the same as multiplying it by the upside down fraction. And so yeah, and I know how to multiply fractions, so that's not a problem. So x plus 5 multiplied by all of that is exactly the same as x plus 5 multiplied by the upside down version of that, which is this. And then I thought, oh, and then we did forget to add the 6, but we remembered before it was too late, and we put it in afterwards. And that did cause another problem, didn't it? That was a difficult bit. But at this point, I want to simplify this bit. And I thought, well, maybe what I want to do is if I factorize the bottom equation, perhaps I'm going to get an x plus 5 or maybe an x minus 1, and they would cancel out. And sure enough, that's exactly what happened. I thought to myself, well, I know that I need two numbers that multiply to give minus 10, and add to give plus 3. I thought, well, 5 and 2 multiply to give 10, so one of them would be a negative number. If the 2 is a negative number, then that would be 5 minus 2 to give positive 3. And then I was like, oh, that's awesome, because we need a 5 up there, so we're going to end up with an x plus 5 along the bottom, and therefore these are going to cancel out. So we ended up with this, and then we got all excited and we thought we'd done it, and we realised, oh no, the 6. So we had to add the 6 back in, and we're like, well, how do I get that 6 sorted out? So after a bit of faffing about, I thought, well, what about if I do x minus 2 divided by x minus 2, which is just 1, multiply that by 6, and that would be the same as 6. Now, why do I do that? It's because I now have two fractions which I can add because they have the same denominator. So I added the tops of each one, put them together like that, both over x minus 2. At this point, we should be able to see light at the end of the tunnel because we've got two linear equations being added together. So we're going to get a linear equation at the top, which is what we want. Linear equation, by the way, just means that x is not to the power of anything greater than 1. Well, x is just to the power of 1, any x's. So then I collect the terms. I've got x over here, got 6x over here, collect them together for 7x. Then minus 1 minus 12, that comes to minus 13. X over 2 at the bottom stays the same, and that's the answer. Oh, well, that's not the answer, sorry, because now we have to look at that, compare it with the form up here, and we can see, therefore, that, let me just get my pen here. We'll say that, well, we can see from here that A must be equal to 7, because it's 7x at the top. B is equal to not negative 13 because they're minusing B, so ours is just B is just 13. C would be equal to 1, and D is equal to 2. So that's the. Although does it? I don't know if we have to actually do that for the question, but in any case, yeah, that would cover all bases.